Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Imran bin Hisham. So my other friend is Haji Aikar bin Yusri. So we from Group 4 CEEE 2234D want to present about our project, which is mental health crisis evaluator among students. Alright, we are here at the first. In recent years, especially follow the disruptions of the pandemic, mental health concerns among university students have significantly increased. These issues, such as anxiety, depression, and stress, have started to impact academic performance, time management, and overall well-being. Our project aims to explore these relationships using a combination of data analytics and IoT-based monitoring system to provide meaningful insights and proactive solutions. So we move to problem statements. So, although mental health challenges are widespread among university students, many institutions lack structured system to monitoring or respond to these issues effectively. Emotional distress, academic burnout, and low engagement often go untracked. There is a clear gap in understanding how mental well-being directly affects GPA, study behavior, and academic outcomes. Our goal is to fill this gap by analyzing real-world student data collected from 2020 to 2023, which is 4 years, and to support informed decision-making through predictive modeling and visual monitoring. So we move to next slide. So, in monitoring system overview, our system integrates a machine learning model with an IoT platform called ThinkSpot. It continuously monitors critical academic and mental health indicators like CGPA, anxiety study hours, sleep quality, and more. These variables are transmitted in real time to a dashboard using MQTT protocols. The ThinkSpot interface displays line charts, pie charts, and bar graphs, allowing administrators or counselors to track trends, identify at-risk students, and make data-driven interventions. So this three is our objectives, which is to analyze students' performance by between student mental health academic performance using real data from 2020 to 2023. So we expected the input data, so we can analyze the performance of the students, which is in good performance or bad performance. The second one is to identify the key factors, which is to identify the key factors affecting academic outcomes such as GPA, sleep quality, study habits, stress levels, and access to support services. So we consume that's all the input data. So the output data, which is the support services, we can summarize what kind of support services or the student is need. Is it the students need the support services? The last one is to apply machine learning and statistical methods to discover patterns and provide insight for improving student well-being and academic success. So this can conclude the data for the data summarization. So the university can make the chat as their baseline, or then can take next step or further step to prevent the mental health among students. So we move to descriptive analysis. So in descriptive analysis, we have two figures. So this is the first figure, and then this is our second figure. So in descriptive analysis, we export data from 1,001 students across multiple years and faculties. We found that around 48% experienced depression, 47% had anxiety, and 46% suffered panic attacks from the data we get from the descriptive analysis. So interestingly, only 6.7% had received professional treatment. The average CGPA was 3.12 and students studied about 9.75 hours weekly. So which is this more than one per three, 1 per 4 day in our life. So, but stress and sleep quality average around 3 on a 5-point scale, suggesting room for improvement. This descriptive finding highlight the prevalence of mental health challenges and their possible connection to academic struggles. In correlation analysis, our correlation method reveals some expected and unexpected relationships. Most significantly, study hours and CGPA had a strong positive correlation, which is 0.93, confirming that consistent study habits lead to higher academic success. However, sleep quality and mental health symptoms show very weak correlation, which challenges common assumption. Also, anxiety and depression were not highly correlated with each other, possibly indicating different manifestation or reporting patterns among students. Interestingly, access to professional support had a perfect correlation with receiving specialist treatment, suggesting better access to care if the student get full support or none at all. So this is a type chart of data. So I will pass to my friend Haziq.
So we'll talk about type of data chart. So the first one is the column chart. So the column chart shows the title of depression by gender. But for this chart, we use the coding by Jupyter to create the column chart. So for the column chart, the the x-axis shows female and male, and the legends only said about the blue color is for depression. We use the binary output, which is 0 for no and 1 for yes. So, and the y-axis shows the values, but the values is not like categorized. So there should be a way to fix this. So by adding a very descriptive legend which shows on which one is the precise one, and then we also need to use distinct colors, which is one color for no depression and another color is for depression, applied consistently with each gender, and should be able to label the x-axis and y-axis precisely. And next. So next, this is the box plot. So the box plot also have the title of the CGPA distribution by anxiety levels. But in this box plot, shows that x-axis is anxiety and y-axis is CGPA. But shows that x-axis shows that 0 and 1. But there's also no legend explaining what they mean by likely what is 0 and what is 1. So just for the assumption, with 0 is low anxiety and 1 is for having anxiety. So this also shows that using the Jupyter also have lack of context because there are no indication of sample size per group and no measure for the statistical spread. So this will be making viewers have limited visual detail because the data lacks of comparison, and it's difficult to make the conclusion based on the chart itself. So to to improve this, just like the first chart, we also can label the axis clearly and add some legends to to make the viewers identify so that conclusions can be made based on the box plot itself. Next. So the third one is pie chart. So the next three charts that we found are by using the analytical data from the Excel. So we use the data set and then we ask Excel to analyze the data, and it will show us a few charts that we can choose. So the first chart that I choose from the Excel is the pie chart. So this clearly can show the key observations, which is the year one students. Uh, report is the highest mental health issues, which anxiety have 200 and depression have 193 students. So trends across the academic years, year 2 have a moderate level, and year 3 has a slight drop in anxiety, and year 4 has lowest level. So in year here, it means that the student is on the first year, the second year, the third year, and the fourth year. So we can slowly make the conclusion that the total cases, anxiety have the 474 cases and depression have 480 cases. So this will show the percentage of the distribution of the students based on the year that they're having anxiety and depression. So on the first year is 42%. The students for second year is 27%. The students for year 3 is 24%. And student for year 4 is 7%. So next. So the next one is basic line chart. So this shows the age comparison of male and female students, which is male students average age is 21.44 years, which is basically, if we round it, about 10, only male student mostly is 21 years old that's having the mental health crisis, and our female is 21.39, also this same as male. So the overall average age is 21.4 years. So in this case, age differences is negligible, suggesting support patterns are not age driven. So support access by gender is female students have 51 cases of reported support, while male students have 16 cases. So females are over 3 times more likely to report having a mental health support than males. So for the implications, mental health service shows clear gender disparity not related to age. So the conclusions can be made that males have less mental health crisis. So male students have not likely having to have support for these mental health crisis issues. So next is the point chart, or we call as scatter plot. So from this chart, we can observe that x-axis shows the study hours per week, and y-axis shows the CGPA. So in here, x-axis is going up, and y-axis is at the bottom. So these labels suggest a very strong positive correlation between study hours and CGPA. But from this chart, there's are regression. So for the next one, we go to the ML regression or coarse linear regression model for predicting the CGPA. So in this regression, we it shows the model performance, which is the mean squared error (MSE), having the value of 0.0679. So this indicates extremely small prediction errors between the actual versus predicted CGPA. And then for the R squared value is 0.8973. So this model explains about 89.73% of the variance in CGPA. So this linear regression suggests a very strong fit to the data. So for the visualization inside, so scatter plot, this regression shows that scatter plot compares actual versus predicted CGPA ranging between 2.00 to 4.00. So most of the data points cluster tightly around the perfect prediction line. So it confirms that predictions are very close to the actual values. So in implication for education, CGPA can be accurately predicted using measurable factors like study habits, academic engagement, and mental indication. So it is useful for early warning systems, academic support targeting, and personalized advising. Also for the resource allocation. So next, we go to the decision tree model. So this decision tree models shows the decision tree classifier for predicting the depression. So this model setup, it is built as a decision tree classifier with a maximum depth of 3. It also shows that we train on 800 student samples using academic and demographic features. So for a starting point, we use all the 800 samples, begin at the root. So for the first split condition, it shows that CGPA is less than 2.855 because this is the most influential decision factor. So next we go to the left branch. So it shows that CGPA is less than 2.855. So 320 samples are following this path. So majority of this class branch shows there's no depression. So for the gene impurity, value is 0.489, so it is moderately impurity. And for the next split, it's academic engagement, which is less than 3.5. So this further divides to improve the prediction accuracy. So next is the right branch. So for the right branch, the CGPA is more than 2.855. So there are 480 samples following this path. So the next key split is study hours per week, which is less than 30.5. So majority of this class from this branch having depression. So we can suggest that it suggests that even high performing students may be depressed if overstudying or stress. So for further splits, we can add conditions on age or academic engagement and study hours per week. So each condition will reduce its impurity and improve classification confidence. So for the leaf nodes or the final outcomes, so the final decision is made at leaf nodes after 3 levels of splits. So each path ends in a predicted label, which is having a depression or no depression at all. So for the conclusion of this decision tree model, this tree shows a strong and interpretable logic behind predictions. So CGPA, academic engagement, and study hours per week are the key for having depression, or we call as a depression indicators. So this decision tree model is useful for early screening and understanding academic mental health dynamics. So next, we go to the ThinkSpot simulation. So the ThinkSpot simulation, so the ThinkSpot simulation. So this is the figure of the dashboard from the IoT platform ThinkSpot. So firstly, we will use the coding, and from the coding, we can link to the ThinkSpot application platform by having to access using a token. So the token will be given in a code. So we will insert the token into the coding for the ThinkSpot and upload our dataset file into the code as well. So if the ThinkSpot platform and the Excel and the codes is linked, so we can it will be activated. So after the ThinkSpot has activated, we can go to the dashboard and add some widgets to analyze a real-time based data. So for the first one is the line chart. So the line chart uh, is a real-time chart of age, CGPA, and sleep quality over a 1 minute period. So for this real-time line chart, so age is constant at 2112. So it will suggest a consistent and valid participant data. And then for the CGPA, there's a slight fluctuation, but only averaging around 3. So it indicates stable academic performance during the time window. And the last is the sleep quality, also varies slightly, averaging near 3 on a possible 0 to 5 scale. So it suggests moderate and steady sleep quality. So for the interpretation of this line chart, so data appears to be stable over the period because there's no major shifts observed. So it is likely present health or academic monitoring, such as sleep versus a performance tracking. So it needs it shows the clarification needed on how CGPA is being measured in real-time based data. So for the line chart, the parameters remain relatively steady, and it is useful for short-term monitoring and system reliability checks because there's no sudden changes detected during the observed minute. So next is the bar chart. So the bar chart is also a real-time based bar chart over a 1 minute period. So the metrics that we track is study stress level, which shows a stable mid-range percentage. So it suggests only a moderate stress is detected. Next is study hours per week. So in the bar chart, it shows a consistent values throughout the chart. For the CCPA, it remains constant during a 1 minute observation. So for the interpretation of this bar chart, so all three metrics shows a remarkable stability because there's no significant fluctuations occur. So we can suggest that either student have the routine behavior or having a controlled observation period. So for this bar chart, data indicates no sudden changes in study habits or stress. So it can support as an early monitoring tool for academic support or behavioral insight. For it also shows further details on grading and scaling methods that will aid deeper interpretation for the data. So next is a real-time point chart over a 1 minute period as well. So for this point chart, the metrics that we track is the sleep quality, which shows that it peaked at 13, that indicate a very strong or a restful sleep levels. Next is the study hours per week. So it also peaked at 12. So it also indicates that student has a high study commitment. Next one is the study stress level. So there's only a mild fluctuations between 3 and 6. So it shows only a few students have a moderate stress during their studies. And for the academic engagement and CGPA, both remain stable at 3, which suggests that students have the consistent academic performance. So for the interpretation for this point chart, the high study and sleep value exists alongside steady CGPA and academic engagement. So this point chart suggests a possible lag in academic impact or short time frame for changes to appear. So from this point chart, it shows that performance and habits are stable during the short observation. So maybe it needs a longer monitoring so that we can see the academic changes from the data. We also this chart also can formatting a quick burns uh, so that we can be part of a larger monitoring tool or maybe a type system. So next is a real-time CGPA grouping chart, or we call as a range chart. So this chart purpose actually groups students into CGPA performance brackets for quick academic monitoring. So it is likely used by teachers or administrators to track student progress in a real-time based data. So the benefits and use for this type of chart, it allows a fast assessment of overall class performance, and it also helps in identify struggling students or academic outliers, and useful for tracking trends and setting interventions. So from this data, there's actually no clear elements because 20 to 0 range may be a data entry error or represent a probation, or number like 3 and 2 at the top might indicate that there's a threshold or a class count or maybe an active group of total. So for the conclusion, this kind of chart is simple but effective visual tool for a real-time academic grouping. So it may need a clarification on ambiguous labels for full accuracy and interpretation. So for the last one is the pie chart. So the pie chart shows the academic engagement, CGPA, and sleep quality summary. So for the academic engagement, so the total for this data breakdown is 24 units. So academic engagement has 19 units, which shows 79%. Also shows that this academic engagement dominates the distribution. Next is the CGPA, which have 4 units, which have 17%. CGPA also a significant but a secondary factor. And lastly, sleep quality, which have 1 unit only, shows that 4%. So it is a very low representation. So the total of the 24 units may represent a composite error, a student sample count, or maybe activity weights in the dashboard. So academic engagement outweighs the other two metrics. So this chart may suggest that students focus more on academic tasks, or maybe possibly less data or less priority given to sleep. So for this kind of chart, possible use case is maybe it's useful for teachers or researchers to understand on how students allocate time or effort on their studies, or maybe the imbalance between academic focus and rest. So for this kind of pie chart, maybe only high academic engagement is observed, but very little sleep quality recorded. It could prompt a further study on long-term sustainability, impact of sleep on academic performance, or balancing student routines for better outcomes. So I pass it to Imran.
All right, thank you, Haziq, for the explanation. So, all right, so we move to conclusion, which is at our last slide. All right. So for this slide, for the conclusion, Our research confirms the strong impact of study behavior on academic success and sheds light on the widespread but often unaddressed mental health issues faced by university students. Using linear regression, we achieved nearly 90% accuracy in predicting CGPA, and our decision tree model provided clear pathways for identifying students at risk of depression, and integration with the ThinkSpot IoT platform demonstrates how real-time monitoring can be applied not just in engineering system but in societal applications like students' wellness. Moving forward, we advocate for universities to implement personalized tech-driven mental health support system to create healthier, more productive learning environments. So, just from us. So, thank you and Assalamualaikum.